So the problem says there's a particle. Well, there's a particle with this velocity. It's e to the t, where time is measured in seconds. It moves in a straight line. How far does the particle move from t equals 0 to t equals 2 seconds? Okay, so how far does the particle actually move? Now, is that total distance or is that displacement? I guess we should talk about total distance and displacement for a second. There's total distance, displacement, and new position. Okay, if you guys, we're gonna make up a situation here. We have a particle is at we'll say 2. Okay, so a particle is at 2. Guys, where would we be if I say the particle moves positive 4? Where would we be? The particle would move positive 4. It moves to the right, correct? And then the particle would be at 6. And then I say, all right, now the particle has a negative velocity, so it moves negative 10. Okay, so we move negative 10. Where would the particle be now? We're right here, right? And then we move negative 10. So where would we be? Negative 4. Okay. So we have a bunch of different things here. We have displacement. There's a couple of key words. We have total distance. And we have new position. Okay, so what is our displace? Actually, which one would be the easiest one to find? Which one is the easiest one to find for you guys? Do you know any of those? Okay, then I'm just going to take a guess because everybody's being quiet. I think total distance is the easiest. What is the total distance?
14.
It is 14. Now, if you guys wanted to find total distance and you were given a velocity function, then what you would do is you'd have to take the absolute value of it and then add everything up. Okay? And the reason why you have to take the absolute value is because you have to change this 10 to a positive and then add the 10 into 4. You guys got that? Okay. Displacement. Actually, new position is probably the next easiest one. That was pretty obvious. What's our new position? Yeah, it's negative 4. Okay, and we'll talk about new position in a second once you guys can say what the heck displacement is. What is our displacement? What'd you say? It's so quiet. It's right here. Okay, so this is where we started, right? And this is where we ended. What is that? That's negative 6, right? So negative 6 is our displacement. If you did this integral of the velocity function without the absolute value bars, you would get negative 6. This one will give you 14. So if you wanted to find the new position, then you would want to have 2 plus the displacement. Because the displacement it kind of shortcuts it. It doesn't do all the extra stuff. Okay? Displacement would be the negative 6. Actually this one right here would equal negative 4. But that's how all these work. So we got displacement, total distance, new position. This one's actually, honestly, kind of hard for me to understand what it wants here. It says the particle has this velocity. How far does the particle move? Okay, so that makes me think it's a displacement, but you know what I mean? Like that's
total distance.
Total distance? Yeah, because I'm also thinking that could mean total distance. So I think I'd just call this one a bad question. But anyways, let's go from 0 to 2 and figure this out. Oh, you know what though? It doesn't matter. Total distance and displacement would be the same. You know why? Because E is always positive. It looks like this. See how it's always above the x-axis? It's always above the x-axis, so it's always positive. So it doesn't matter if it's displacement or total distance. So what we're going to have to do is we're going to have to take the antiderivative of e to the t, which is actually pretty simple. It's just e to the t. And then we're going to plug in 2 and 0. So we get e to the 2 minus e to the 0. What is e to the 0 power? 1. I don't know what e to the 2 is, so I'm just going to leave it. So we're going to e to the 2 minus 1. And it looks like that is our answer. See right here? Yeah, booyah. Okay, does it give us any units in this problem? Doesn't give us any units. Okay, so that's it for that one. Let's do this problem right here. A particle with velocity where t is time in seconds. Okay, so we got some seconds here. Oh, that one had seconds too. Moves in a straight line. How far does the particle move from 2 to 3 seconds? Again, we have another situation where we have a problem that is never, it's never negative. Okay, t squared plus 3 would be at 3. We put a 3 right there, and it would be this parabola thing. Okay, so we're going from 2 to 3 of t squared plus 3 dt, and it's the same thing, except this time we have to do the antiderivative rule with the t squared and the 3. So we would get 1/3 t to the third plus 3t, and then we'd have to plug in 3 and 2, subtract them, and that's going to give us our final answer. And that will tell us how far the particle actually moves. And I'm not going to finish it. So if you do that all right here, you do this out, you get 9 and 1/3. Or what would that be as a mixed number or improper fraction? That would be 28 over 3. Yeah. It'd be 28 over 3.